we're going to take a look at how to write sequences and come up with recursive definitions of sequences. So the idea with a sequence, it's a function, and the inputs are just natural numbers. So numbers from 1 up to infinity. However, most of the ones we talk about usually go from 1 to 50 or 100. And first thing is to get recognized and understanding what the sequence notation means. So we're going to talk about exercise 1, and they give us some examples, and they give us a sequence of numbers. It's just a list of numbers that has some sort of relationship. So like 4 is the first term, 8 is the second term, and then so on and so forth. So to find a of 3, you'd look for the third term, and in this case this would be 16. And then they have you do some different arithmetic things with it. If you look at b, the first term plus the seventh term. So the first term is 4, the seventh term is 256. So the answer would just be by adding those together, you'd get 260. C is just a different way for the same thing. It's the second term in the sequence A, which would just be 8. For D, they want you to take the first term and square it. So 4 squared would be 16 again. And then for E, they want you to take the fifth term and the fourth term and subtract them. So it's 64 minus 32, which would be 32. And they want you to solve for this. So if you're looking for what n is going to be, well, in that case, it's going to be the sixth term. That gives you an answer of 128. So this is just some basic, substitution. You're taking numbers and you're replacing them with what term they're talking about. They are functions. So if you look at a sequence, one key thing to notice is that not every value is going to be part of a sequence. They give us this rule, this formula, 2n plus 1. So the first 5 elements would be these numbers. They would be 3, 5, 7, 9, and 11. That would be your first term up to fifth term. And when you graph this, when you graph these points, like I'm doing right now, the important thing is that you're not connecting these points because those numbers represent a sequence and those are the only answers. So when we're talking about a straight line, well, those other numbers aren't involved. There's no decimals. Remember, a sequence is just the natural numbers, 1 through however high you're going. And if you want to find the 21st term, there's a couple ways you could do that. Really, the 21st term, you would have to take n and replace that n with 21. So you'd have 2 times 21 plus 1, which would end up being 43. So that would be the 21st term in the sequence. Now, moving on for that, we're going to talk about how to write a recursive definition. So if you take a look at exercise 3, this is an example of a recursive function. And recursive, they call it recursive because you're using the previous answer to find the next answer. So when it says a common sense interpretation, they're just asking us what this means. And what this means, this first part means that 7 is the first term. That's what the red circle means. And then this part tells you what you're changing by to get the next term. So the next term, is the previous term. And then added to 4. So the first 4 terms, well, we know 7's the first one. And the next 3 terms would be 11, 15, 19. And they say do the first 4 except for B1. So the next one after that would be 23. So for this, it's really important to understand what mathematics are taking place. You have your first term here, and then you have how it's changing to get the next one. Kind of moving on from there, exercise 5, this one asks us to create, and it's fairly similar to linear functions. So it says Kirk is trying to train for a marathon. His first month he runs 5 miles. He adds 3 miles each month. So that would mean that every month is getting increased by 3, which is very similar to what a linear function is. Those are the amounts he's going to run each month. And then for the recursive definition, well, we know that the first term is going to be 5. And then to get each next term, to get the next term after that, a of n, you take the last term, which would be a of n minus 1, and then you're adding 3 to it. So this would be your recursive definition for this. And again, there could be other ways to write it that aren't recursive, but could be accepted. Sometimes they call them an explicit formula. And in that case, that would be similar to a linear function. If we did a of m, it would be 3m plus 5. So that would be your explicit formula. So if you have 3 times 2 plus 5, and then sorry, my mic just cut out. My mistake, that's not plus 5, that's going to be plus 2 in this case. Because I put plus 5 in, the table wouldn't match up. So in this case, if you had 0, it would be 0, 2, and you're increasing by 5. So that would be your, in this case, explicit formula, and in part B, they're looking for the recursive. Now you can go ahead and graph those points for part C, and then move on to the work on the next page.